Constant velocity problems, example 3. An object is initially at the point A, 5, -5, and has a velocity vector of -2i plus 4j, where I is a unit vector due east and j is a unit vector due north. Distance units are meters and time in seconds. State the position of the object at time t. Well, we know that it starts at 5, -5, so that's where it needs to be when t is 0. And then the velocity is -2, 4, so every second it's going to travel 2 meters, -2 meters, and if we look at that, that means it's going to go west, and 4, which means it's going to go north by 4. So we know that this is the velocity vector. So the speed of the object, so we know that v is -2, 4, and therefore mod v is going to be the square root of 2 squared plus 4 squared, which is root 20. And we could give that as a calculated answer. So if we do the square root of 20, that gives us 4.47. So we're going to say that that is 4.47 meters per second, correct to 2 decimal places. When is the object due east of O? Well, in order to be due east, we think about, so this is east over here, west, north, south, and the object started down here somewhere and it's traveling in this sort of direction. So therefore, we want the j component to be 0. So it's going to be when the j component is equal to 0. That way, it's neither north nor south. It's only going to be east or west. So that gives us -5 plus 4t is equal to 0. That's the j component, which is the north-south. So 4t is equal to 5. T is going to be 1.25 seconds. When is the object due north of O? So that's when it's actually arrived at a point here. And for that, we're going to need the I component to be equal to 0, so that it's neither east nor west, just north or south. So that's going to give us 5 minus 2t. So 5 minus 2t is equal to 0. So 2t is equal to 5. So t is going to be at 2.5 seconds.